the last video, I mentioned that finding a vector's magnitude follows the same pattern as isolating the hypotenuse in the Pythagorean theorem. But why? Here's a visualization. Now suppose we have the vector 3, 4, 12 in 3-dimensional space. Just to make it easier to visualize, I'll place the vector at the origin, so its endpoint is the point 3, 4, 12. Now we want to find its magnitude. But we can't directly apply the Pythagorean theorem yet, because we don't have a right triangle. So first let's draw a supporting line along the ground. Notice that if we can find the length of this line, it becomes one side of a right triangle, with 12 as the other side and our vector as the hypotenuse. Then we can use the Pythagorean theorem to find the magnitude of the vector. So let's find the length of the line on the ground first. Its two components are 3 and 4, so we can apply the Pythagorean theorem. So the length of this line is 5. Now we have another right triangle with side lengths 5 and 12, so apparently we can just use the Pythagorean theorem again. But wait a second, 5 came from the Pythagorean theorem we just used, so instead of writing 5 squared, we can replace it with 3 squared plus 4 squared. In other words, we can take the Pythagorean result from a lower dimension and use it again in the next dimension. And there's nothing stopping us from repeating this process. Every time we add another dimension, we can apply the exact same idea again. So this pattern continues into 4 dimensions, 5 dimensions, or as many dimensions as we want.